Hello children, welcome to solve this part 2. In this part I will be solving questions related to cuboid and cube. Okay, so you can open your book, page number 274. Page number 274, last exercise 21C. Look at question number 2. Question number 1. First look at question number 1. Okay. Each face of a cube has a perimeter equal to 32 cm. Each face means square. Each face of a cube is a square. Its perimeter is 32 cm. Means 4a is equal to 32 cm. A is equal to 8 cm. Okay. Each side means edge of the cube is 8 cm. Find its surface area. Okay. Surface area means PSA only, which is 6a square. There are 6 faces, so 6a square. 6 into a square means 8 square is 64. 6 4 is 24, 2 is 36. 384 square cm. So this is the total surface area of a cube. Now let us move to volume. Volume is equal to a cube. Okay, edge cube. What is edge? 8 cm. 8 cube, which is 512 cubic cm. Clear? So this is the surface area, this is the volume of the cube. Clear? Next, move to question number 2. Move to question number 2. A school auditorium is 40 meter long. This is an example of cuboid. 40 meter, breadth is 30 meter. Height is 12 meter. Okay. So these are the dimensions of the cuboid. Means the auditorium which is in the shape of a cuboid. Okay. If each student requires 1.2 square meter of the floor area. Okay. So every student needs 1.2 square meter of the floor area. Find the maximum number of students that can be accommodated in the auditorium. So let us find the floor area. Then we can find the number of students. Area of floor is equal to LB. Length into breadth. It is a rectangle. Okay. So LB means 40 into 30, which is 1200 square meter. So area of floor is equal to 1200 square meter. Okay. If 1.2 square meter is occupied by one student, then 1200 square meter will be occupied by how many students? Using unitary method. So number of students that can be accommodated inside this auditorium is equal to 1200 by 1.2, which is 1.2 means 12 by 10, so 10 will go up, it will become 12,000. So that is 1,000. So total in all 1,000 students can be accommodated in this auditorium. Clear? Next, find the volume of air available in the auditorium for each student. Okay, for each student. Number of students 1,000. Now let us find volume of the volume or capacity of this auditorium. Capacity, volume, same thing. Okay. Actually, capacity means internal volume. Okay. Capacity means internal volume. Capacity is equal to LBH. So 40 into 30 into 12. 40 into 30 into 12, which is 14400 cubic meter. So 14,400 cubic meters. So this much air is available to all the students in this auditorium, and there can be 1,000 students in that auditorium. So how much air is available for each student? So again using unitary method. 14,400 by 1,000. So volume of air available for each student. Okay. Volume of air for each student. Okay, for each student is equal to 14400 by 1000. Okay, so 0000 cancel. 14.4 cubic meters. So the quantity of air available for each student in cubic meters is 14.4. Okay. Next, question number 3. Question number 3. The internal dimensions of a rectangular box. Okay, imagine I do not have any box, so I cannot show you. Imagine that there is a rectangular box whose internal dimensions are 12 cm, x cm and 9 cm. Okay, L is equal to 12 cm, B is equal to x cm, H is equal to 9 cm. Okay, if the length of the longest rod means it will be placed from one corner of the room, means one corner of the box to the corner opposite to it, means in the shape of a diagonal. The rod inside the box will be kept in the form of a diagonal, and we know the formula for diagonal. Okay, and the length of the rod is, means diagonal, is 17 cm. D is equal to 17 cm, and we have been asked to find x. Okay, we have been asked to find x. L square plus b square plus h square square root is equal to d. Okay, L square means 12 square is 144, b square means x square, h square means 9 square, which is 81. This is diagonal is 17. Diagonal is 17. Okay, so x square plus 144 plus 81 is 225 is equal to 289. If you square both sides, you will get the square root will be removed and this 17 will become 289. The square is 289. So x square is equal to 289 minus 225, which is 64. Okay, x is equal to square root of 64, that is 8 cm. So the breadth of the box in which the rod has been kept is 8 cm. Clear? Next, question number 7. Question number 7. A rectangular tank 30 cm by 20 cm by 12. Dimensions are given 30, 20, 12. Okay. These are the dimensions of the rectangular tank. It contains water to a depth of 6 cm. Okay, 6 cm. So let us draw a diagram. Actually 3D picture cannot be drawn here, still try to understand. Side view of the container. Suppose this is 30 cm. Breadth I cannot show, 20 cm I cannot show, and this is 12 cm. Water was up to this. Okay, this is, there was water up to 6 cm. Up to 6 cm. Then what happened? A metal cube of side 10 cm is placed in the tank. In the second phase, same water tank, means same tank, same dimension. Okay, this is 30 cm again, 30 cm. This is 12 cm. Water was already there. up to a height of 6 cm. Then a metal cube was placed inside it. So definitely there will be some rise in the level of water. Okay. Suppose this is 10 cm. The edge of the cube is given in the dimensions. This is the cube. Okay. Now the height of water will not be 6 cm, it will be definitely above 6 cm. Okay. Suppose now water is here. Now water is here. This height is not known to me. It is definitely greater than 6 and less than 10 because height of the cube is 10 cm. Okay. This is the second part. Then find the volume of water in liters that must be poured into the tank. Means we have to pour some extra water into the tank so that the metal cube is just submerged. Okay, so in the third phase, suppose this is the cube. My diagram may not be accurate. This is the cube. This was the level of water in the second phase. We will pour some extra water and we will make the level of water reach here. Okay, means 10 cm. This is 10 cm and this is 30 cm. So from these three diagrams you have to understand what has actually happened. First there was water up to a height of 6 cm. Then water was there. A metal cube was gently placed inside the container. So the level of the water rose. There was rise in the level of water. Now the height of water is definitely more than 6 cm. How much it is, I don't know. Then the final level of water has to be 10 cm by adding or by pouring extra water into the container. So our question is how much extra water has been put or how much extra water has been poured inside the container so that the level of water reaches 10 cm. Okay, that you have to find. For that, you need to know the original volume of water which was inside the tank, means inside the container. This is the original water inside the tank. Okay, so let us find original volume of water in the tank or in the container in the tank. Okay, in the tank is equal to, now see the diagram, first diagram. Look at the water. Imagine that you are able to see the water. The water is in the shape of a cuboid because it is inside a cuboid. Water takes the shape of the container in which it is placed. So water has taken the shape of a cuboid. Okay, imagine that water is in solid form. Its length is 30 cm, breadth is 20 cm, which I have not shown. I cannot show it because it is 3D, 3-dimensional, and height is 6 cm, not 12 cm. Height of container is 12 cm, means tank is 12 cm, but height of water is not 12 cm. So since the water is in the shape of a cuboid, we can use formula LBH, where height is not 12 cm, it is 6 cm. Length is 30, breadth is 20, height is 6. 3600 cubic cm. So this is the original volume of water inside the rectangular tank. 3600 cubic cm. Now look at the second diagram. When the metal cube is placed inside it, whose edge is 10 cm, there is rise in the level of water, but there is no increase in the volume of water because it is the same water. The same 3600 cubic cm of water will be here, the second phase. Look at the third phase, some extra water has been poured. Suppose this was the height of water, level of water in the second phase. This is the final phase, final height, 10 cm. Some extra water has been poured. Okay, some extra water has been poured in order to make the level of water 10 cm. Okay, so what is the extra amount of water poured? We will calculate that later on. First let us see, look at the diagram. Can I say here total volume of water. Okay, don't think about this 3600 or don't think about the increase in the volume of water or how much extra water has been poured. Simply think of the total volume of water present here. The total volume of water present here plus volume of the cube. Okay, because the cube is also inside the container. So volume of water plus volume of cube is equal to volume of this cuboid. Look at the cuboid, means container, tank. Volume of this cuboid, volume of the tank till 10 cm height, not 12 cm, 10 cm. Volume of water, total volume, plus volume of cube is equal to volume of the tank till 10 cm height. Okay, from that you can find the final value. So remember this 3600, I am going to erase 3600. Okay, 3600. So final volume of water plus volume of cube is equal to volume of tank till or up to, we can write up to volume of tank up to 10 cm, not 12 cm. Okay, 10 cm. Suppose final volume of water is x. Okay, final volume of water is x. I take it. The volume of cube means 10 cube. As is 10, so volume of cube will be a cube means 10 cube. Now volume of tank up to 10 cm means LBH. Length is 30, breadth is 20, height is 10. Okay. So x is equal to 6000 minus 1000. 30 into 20 into 10 is 6000. 10 cube is 1000. So which will give you 5000 cubic cm. So this is the final volume of water, 5000 cubic cm. The original volume of water is 3600 cubic cm. So how much extra quantity of water has been poured into the container? Definitely 5000 minus 3600. Okay, so the answer is quantity of water poured means extra water poured to submerge the cube is equal to 5000 minus 3600, which is 1400 cubic cm. This is the extra quantity of water that has been poured into the container, 1400 cubic cm. Now we have been asked to give the extra quantity of water in liters. Okay, remember 1 cubic cm is equal to 1 ml. Remember this for water, 1 cubic cm is equal to 1 ml at standard temperature and pressure, STP physics. Okay, 1 cubic cm is equal to 1 ml. So 1400 cubic cm is equal to 1400 ml. Same thing. Okay, ml cubic cm same. And ml can be converted to liter. It is very easy. You know this. By 1000 means 1.4 liters. So the extra quantity of water that has been poured into the container in order to submerge the cube is 1.4 liters. Okay. liters. Next, question number 8. The dimensions of a solid metallic cuboid. Dimensions are given 72, 30 and 75. Okay. 72, 30 and 75. Okay. It is melted. Okay. It is converted to liquid, melted and recast into identical solid metal cubes. Okay. It is melted and formed into many small, identical, similar type, means same size metallic cubes with age 6 m. Age equal to 6 m. Means age of each cube formed is 6 m. Find the number of cones formed. Okay. In such a question where there is a question of melting, means conversion of solid from one form to another, from cone to sphere, from cuboid to cube or cube to cuboid, in such question there is no change in volume. Okay, simply the shape will change, but there is no change in volume. Okay, so LBH means volume of the cuboid will remain the same even if it is formed into different cubes, is equal to n into a cube. N means number of cubes, a cube is the volume of each cube. L 72 into 30 into 75 is equal to n into what is a 6 cube. So n is equal to 72 into 30 into 75 by 6 cube is 216. 6 cube is 216. Let us simplify. Let us cancel. 9 2s are 18, 9 4s are 36, 9 8s are 72, 8 3s are 24, 3 10s are 30. So answer is 750 cubes will be formed. Okay, 750 cubes will be formed. Ready? Next, also find the cost of polishing the surfaces of all the cubes at the rate of rupees 150 per square meter. Okay, the rate is per square meter rupees 150 will be spent. So how much money will be spent in all if we polish all the surfaces of the cubes? So let us find the total surface area of all the cubes. Okay, TSA of each cube is equal to 6 a square. What is a? 6. A square means 36. 216 square cm. Okay, cm? Yes. So total surface area of each cube is 216 square cm. And we have 750 cubes like this. 1. Okay. The surface area of one cube is 216 square cm. We have similar 750 cubes. So the total surface area to be polished. Okay. So surface area to be polished is equal to 750 into, how many cubes are there? 750 into 216, which is 162,000. 162 square cm. Okay, 162,000 square cm. But the rate is given in per square meter. Rupees 150 per square meter. So let us convert this to square meter. Now how to convert this to square meter? See. One square meter is equal to 100 cm into 100 cm, which is 10,000 square cm, or we can say 10,000 square cm into 1 square meter. Okay, 10,000 square cm into 1 square meter. So 162,000 square cm equal how many square meter? Divided by 10,000. Okay, divided by 10,000. 162 by 10,000 square meter, which is 16.2 square meter. Okay, 16.2 square meter. This much area has to be polished, and the rate is given, so we can easily find the cost. So cost is equal to cost of polishing is equal to, okay, 1 square meter how much cost? Rupees 150. Okay, so this much will be 16.2 into 150, which is 16.2 into 150, rupees 2430. Rupees 2430. So this is the cost to be beared in order to polish all the cubes, total surface area of all the cubes. Clear? Move to one more question. Question number exercise 21B, the previous page, page number 273. Question number 21, exercise 21B, question number 4. Question number 4. Question number 4. Exercise 21B, the previous exercise, question number 4. Water is discharged from a pipe of cross section area 3.2 square cm. Okay, so this is the cross sectional area of the pipe through which water is flowing at a constant rate, constant speed. Okay, speed is given 5 meter per second. Speed is equal to 5 meter per second, that means 500 cm per second. Okay, since area of cross section is in square cm, so I converted the speed from meter per second to cm per second. Okay, next, calculate the volume of water discharged in cubic cm per second. Okay, per second. So per second, how much water is flowing through the pipe, or how much water is emerging from the pipe? That is also called volume flow rate. Remember, VFR, volume flow rate. Remember this. Its formula is area of cross section into speed of water. Speed of water or speed of any liquid flowing through it. Okay, what is area of cross section? 3.2 means 32 by 10. Okay, what is speed of water? 500 cm per second. Okay, so what will be the overall unit? Area of cross section means square cm, speed means cm per second. So if you combine, if you multiply in that, cubic cm per second. Okay, cubic cm per second. Don't forget to mention this second, because it is volume flow rate, simply not volume. It is volume flow rate. Rate means you have to take into consideration time also. So 0 0 cancel, 32 5 is 160 0. This is the answer. So this much quantity of water, 1600 cubic cm of water is flowing out of the pipe, is emerging from the pipe per second. Okay. Second bit. Calculate the volume of water discharged in liters per minute. This is in 1 second, so in 1 minute we can easily find. Second bit answer. In 1 minute. This is in 1 second. So volume in 1 minute is equal to 60 into 1600. Okay. In 1 second, 1600. In 1 minute means 60 seconds. Therefore, I multiplied by 60. 60 seconds, 60 into 1600, 96000 cubic second. Okay, 96000 cubic So cubic second, I am saying, sorry, cubic cm. Okay. So this is the volume of water that will emerge out of the pipe in 1 minute, 96,000 cubic cm. And we have been asked to give the unit in liters. So we know that cm, cubic cm is equal to ml. Okay. So we can write 96,000 ml. No difference at all. Cubic cm equal to ml. Then you can easily convert to liters by dividing by 1000. If you divide this by 1000, you will get 96 liters. So the volume of water that is emerging out of the pipe in 1 minute is equal to 96 liters. Clear? So this is the answer. Question number 5, same exercise. Last question of this part, of this chapter also. This is a very small chapter, you will practice only. I have solved some questions. Question number 5. A hose pipe, okay, means a big pipe having good. A hose pipe means a pipe through which water flow means comes out at a very high speed, okay, which are generally used by police personnel or by fire brigade, okay, hose pipe. Of cross section area of cross section is given. Area of cross section is very small. Okay, 2 square cm is very small. It should not be so small. Delivers 1500 liters of water in 5 minutes. Okay. 5 minutes is equal to 5 into 60, that is 300 seconds. Minute is not important to us, second is important to us. Okay, you might know speed of a vehicle is given in kilometer per hour or meter per second. It is not given in per minute. Okay, so I have converted minute to second. 5 minutes is equal to 300 seconds. Now in the question it is given that in 300 seconds how much water is flowing out of the pipe or emerging out of the pipe? Discharged 1500 liters. 1500 liters. So in 1 second, using unitary method, how much liter will be discharged? 1500 by 300, which is 5 liters. Okay, 5 liters. Now 5 liters can be converted to ml. 5 liters is equal to 5000 ml, and this ml can be converted to cubic cm. So this is the volume of water flowing out of the pipe in 1 second, or in other words, this is volume flow rate. Okay, 5000 cubic cm of water is flowing out of the pipe in 1 second. That means the volume flow rate of the pipe is 5000 cubic cm per second. Very simple. Okay, so VFR is equal to, VFR was not given to us, and we cannot find within the original formula, means area of cross section into speed. It is not applicable here because area of cross section is given but speed is not given. Okay, so we cannot find the volume flow rate in the original using the original formula. So we used unitary method and found out the volume flow rate VFR. 5000 cubic cm per second. Okay. Now what is VFR? Area of cross section into speed. Area of cross section is 2, as you can see. Area of cross section is 2. Okay. 2. Speed we don't know. Okay. Speed we don't know. That is our target. We will find per second. So speed is equal to 5000 by 2, which is 2500 cm per second. Speed is always in cm per second. If you divide cubic cm per second by square cm, you will get cm per second. So this is the speed of water inside the pipe in cm per second, 2500 cm per second. and we will ask to find the speed of water in meter per second. So let us convert this to meter. Okay, if you want to convert cm to meter, then you have to divide by 100. So 2500 by 100 meter per second, which will give you 25 meter per second. Okay, 25 meter per second. If you want to convert to kilometer per hour also, you can do it. Okay, how? This 25 meter per second. If you want to convert to kilometer per hour, you have to multiply by 18 by 5. Okay, 5 5 is 25, 18 5 is 90. Okay, actually according to the question, this is the answer as per the question. So we have been asked to find the speed in meter per second, not in kilometer per hour. I took it a little further. This is your final answer. But if you want, you can convert it to kilometer per hour. The answer will be 90 kilometers per hour. So it is definitely a horse pipe because water is flowing through it at a very high speed, 90 kilometers per hour. Okay. So I hope you have understood this chapter. Okay, solids. So thank you for watching.